Alright team, today, that's my toddler in the background screaming. Today we are looking at finding the shortest distance from a point. So I'm going to do just a couple for you, from point B to line AC. So the shortest distance will create a 90-degree angle, okay? And that means that we can use trigonometry to find out the distance. We've got an angle here. We've got a hypotenuse here. So what we want to find is this length here, which I'll call x. And we've got opposite. So we've got sine 42 equals the opposite over the hypotenuse. And so x should be equal to 6 sine 42. So that's fairly easy. What does that give us? 6 sine 42 gives me 4.01 centimeters. Okay, so that's how you do those. Now, let's have a look at 5a here. So we've got a line, y equals 2x plus 3. So let's just have a quick think about what that looks like. It crosses here at 3, and then it's got a gradient of 2x of 2, sorry. So at 1 here, this is going to be, what is it going to be, 2, 5, right, so it'll be up at 5, at 0. Okay, now what we're trying to do is find somewhere over here at 6, 5, which is here, and we want to find the shortest distance between the line, y equals 2x plus 3, and this point here. So we're going to draw a perpendicular line here, and that's the distance that we want to find. Okay, well, how are we going to do that? Well, we could find the gradient of this, which is 2, and therefore the gradient of this, since it's perpendicular, must be minus 1/2 x. Okay? Oh, sorry, 1/2. Now, we can actually define this line because we've got a point on it. So we're going to go y minus y1 equals m into x minus x1. So if we define this line, it's going to be y minus the y point, which is, I think we're at 5, aren't we? Yes, we're at 5, is equal to minus 1/2, which is the gradient we figured out because it's perpendicular, minus 6, which is this point here. And we're going to get a line. So we're going to get minus 1/2 x plus, now, minus 1/2 times minus 6 is positive 3, and then we're going to add 5 to that, so I think it should be that. Now, we've got two lines, and we can find the point at which they meet by going, we take this, and then we're going to take this and make them equal to each other. So we get 2x plus 3 is equal to minus 1/2 x plus 8. We pull everything across, so we get 2.5x, and then we pull this across here, we get 5. So x is equal to 2, and then we can find our y value by inserting it into either. I'm going to insert it into this one because it's easier. 2 times 2 is 4 plus 3 is 7. Okay, now we're trying to find the distance between 6, 5 and this point here, which is going to be 2, 7. So that's easy. We're going to use Pythagoras. So we've got our 2 points. These are the 2 points here and here. And so we're going to go square root of 6 minus 2 plus the 7 minus 5 all squared. Well, sorry, 5 minus 7. I should be consistent, shouldn't I? 5 minus 7 all squared. It works out the same anyway. So we get the square root of, what's that, 16 plus, that's 4. So I think it should be square root 20. Now, square root 20 is like square root 4 times square root 5, which is equal to 2 square root 5. And I guess if they want 3 significant figures, that's equal to 4.47 centimeters or units. 4.47. Okay, and that would be how I would solve those ones. So if you're getting stuck with those, use that same method. Take care.